This is a video recording of Chapter 2, Section 2, Comparing and Ordering Rational Numbers. And the objective here today is pretty much that. It's to compare and order positive and negative rational numbers written as fractions, decimals, and integers. Remember, rational numbers are things that can be written as a fraction. And even though the objective there says fractions, decimals, and integers, remember a decimal can be written as a fraction. Integers can be written as fractions. So pretty much all types of numbers are going to fit here. Remember, really the primary exception to a rational number is a number that repeats forever but doesn't have a pattern. Something that does repeat forever and does have a pattern, like your 0.3 repeating type thing, that can be written as a fraction, so that's a rational number. Remember, the other exceptions, things like pi and square roots of negative numbers, which we won't worry too much about right now. So the definition that we have here is least common denominator. That's the least common multiple of the denominators. Of course, denominators implies they're talking about fractions here. That's one thing that we're going to have to work on here is getting equivalent fractions, fractions with common denominators, preferably the smallest one, which is why they've defined that term right there for you. So if we look at the first question, in the first question they're asking us to compare 5, 6, and 7/10, and they're asking us to compare them with greater than, less than, or equal to. So let's take a look at where they start here. There's a couple different ways around this problem, but what they do here with the first method they are presenting to you is to multiply to find the denominator. They're not actually finding the least common denominator here. They're just finding a common denominator. So what you're doing here is you're simply multiplying by the other denominator. So since the denominator here is 6, I'm going to multiply by 10. Since the denominator here is 10, I'm going to multiply by 6, which of course in both cases 6 times 10 or 10 times 6 is going to generate 60. So 60 is going to be my common denominator. Now remember, whatever you multiply the bottom number by, the denominator, you then have to carry the same multiplication through the top. So on this one, when we multiplied by 10 in the bottom, we did the same in the top, and that's how we ended up with 50 over 60. With this one, 7/10, we multiplied by 6 to get to 60, so we do the same thing in the top, and that's how I get 42 out of 60. Remember, when we compare fractions, we don't actually have to look at the denominators then once we have a common denominator. But it's essential you have a common denominator before I can assert that. Once we have that common denominator, just compare the numerators. So we've got 50 and 42. Well, obviously 50 is bigger than 42, which means 50 60ths is bigger than 42 60ths. Now, the only little catch is, remember that this is not the original fraction in the question. The original fraction in the question was 5 6. So this fraction was bigger. Its equivalent form would be bigger, which is how we say here for our solution that 5 6 is bigger than 7/10. Now, what they have us doing here with the second method in a different question is now they actually have us finding the least common denominator to do that. Well, remember, the least common denominator comes from multiples. You have to list multiples of your denominators and find the first number at which you have a match, the first number that shows up on both lists. So in this question, we'd be looking at the denominators, which are 3 and 5. Well, if we go through and list multiples, and when I talk about multiples, I want you to think of a times table. The 3 list is going to start at 3, because 3 times 1 is 3. And then the next number is going to be 6, because 3 times 2 is 6. And then the next number is going to be 9, because 3 times 3 is 9. And we keep going. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, so on. 5 list, same principle. 5, 10, 15, 20, 25, 30. Notice how the list is generated. 5 times 1, 5 times 2, 5 times 3, 5 times 4, so on and so forth. So the first number that hits on both lists here is 15. Now, if you listen carefully to what I just said, they do have a match at 30. That is true, but it's not the first number that's on both lists. Here they did say least common denominator. 30 would just be a common denominator, not the least. So, since the least common denominator is 15, that means we're changing the bottom of both of these fractions into 15. So to change 3 into 15, you would have to multiply by 5, which is why we're then also multiplying by 5 in the numerator here to get 10/15. To change 5 into 15, you would multiply by 3, so I would multiply by 3 in the numerator as well, and that generates 12/15. So now we can compare the fractions since we have a common denominator, 10/15 and 12/15. Well, we know that 12 is bigger than 10, which means this fraction is bigger. Again, the only little hiccup here is that that was not the original fraction. 12/15 started off as 4/5. So here we're going to assert that 2/3 is less than 4/5, or if you read it the other direction, 4/5 would be bigger than 2/3. We'll continue with example number 2, which is more comparison type questions, but as you can see what they're doing now is they're going to start mixing up the various forms. So they're going to start commingling fractions and decimals, and mixed numbers and decimals, and improper fractions and decimals, and all sorts of things of a like nature here in this question. So again, we're going to compare with, less than, greater than, or equal to. And the first question says 5 2/9 and 5 2/7. Now what's kind of nice about this question though is that they took the time just to convert these to decimals, which should be much less work than comparing them as fractions. Because as we just saw, if I want to compare them as fractions, I have to spend time getting a common denominator. But if I want to change them to decimals, that's much simpler because as we saw previously, we're going to take these fraction parts and divide them out on a calculator, numerator divided by denominator. So for instance, 2/9 on the calculator is going to yield a 0.2, and that 2 is going to fill the screen. It's going to be a bunch of 2's across the screen, as in 0.2 repeating, 0.2 with the bar over the top. We append the 5 to the front, and that's how we end up with 5.2 repeating. With 5 2/7, 2 divided by 7 on the calculator is 0.286, and again we append the 5 to the front, and that's 5.286. So we're comparing 5.2 repeating and 5.286. Well, the first spot, the tenths, is both 2's, but the second spot, realize that this one kept going, would be another 2 if we wrote it that way, but this one is an 8. 8 is bigger, and since in that's the first spot we actually have a difference, that's where we compare, because that's how we compare decimals. Since the 8 is bigger, that means 5.286 is bigger, which is why it's written as 5.2 repeating is less than 5.286. But remember, 5.286 started off as 5 2/7, which is why we're going to say 5 2/9 is less than 5 2/7, or if you read it the opposite direction, 5 2/7 is bigger than 5 2/9. Remember, if we go back to that elementary school concept of greater and less than, the alligator always eats the bigger number, and indeed the alligator here is eating 5 2/7. Now in the B question, you have negative 0.44 and negative 2/5. This one's even easier to go all decimal because one of them already is a decimal. So you only have to worry about converting the negative 2/5.